This is Dave with Fry and Bacon Studios and another Game Salad tutorial. In this video, I'm going to start to teach you some of the philosophies of integrated logic. Now, I talk about this all the times on the forums, and a lot of people have been asking me, what is integrated logic? Well, basically, logic is a series of events that has to happen or execute in a particular order for the next event to happen. So in other words, when event 1 needs to happen before event 2 can happen, and event 2 needs to happen before event 3 needs to happen, and event 4 needs to happen, and sometimes these things can string out. Now, I learned this in the electrical industry with heavy industrial equipment like conveyor systems or moving liquids through processes in plants where things and motors and things can't execute until valves are open, until the water pressure is a certain pressure, or it gets low and a pump comes on. So I'm accustomed to dealing with physical items that need to be in their positions in order for the electrical systems to work and be turned on through an automatic sequence. And so dealing with computer logic, you really have to use your imagination, and you really have to think beyond the GUI and think about your code in a way that is logical. So you have to ask yourself, well, if something's not working, what's supposed to happen in order to make this work? And you have to look and see what's working and what's not working. So when we're in the field, let's say in a plant like we worked at Ocean Spray, where they pump cranberry juice through a process of systems where it gets heated and pressurized and stored in tanks, and there are valves that automatically open and close and come on, and air pressure valves. So if we have a system that's not working, and let's say we have a motor that's supposed to be pumping cranberry juice into a tank, and that motor's not working, the first thing we do is we'll go to the source where it's getting its electricity, and we'll test it to make sure the power systems are working. Then we start, when that's all good and the motor's mechanically fine, we ask ourselves, well, what other devices in this process need to be either opened or closed, or what does the pressure need to be? And these all trigger little electrical contacts that are either open and closed that allow the electricity to flow through the circuit, very similar to a light switch in your house and things like that. If the light switch isn't on, the power doesn't get to the light bulb. Well, it's the same way in these plants. So we have to begin to methodically ask ourselves, well, the pressure needs to be right for this motor to come on, and this valve needs to be in the open position. And so we go and we test all these different mechanical devices and the electrical devices to make sure everything's functioning properly, and we look and go through a progression of what things need to be happening. So when we talk about integrated logic, we're talking about streamlining the events that cause something to happen in Game Salad. In other words, we try to boil down things from having 20 different event triggers to a handful of event triggers that we can monitor. So basically, let me just show you what I've got here. I've built this little ship. I think this is probably the best way to start you off with getting an idea or a flavor of what integrated logic is. So I've got this little ship, and it's going to fly a course that I've automated into it. Now, one of the interesting things that it's going to show you is, other than a table, I have absolutely no game level attributes in this. And actually, to do this function, I'm using 2 rules and 2 behaviors. So let's go ahead and let's just preview what's going to happen. So we've got our little ship, and when it flies to each planet, once it gets there, it's going to correct its course and fly to the next one. And it's going to rotate and get its next coordinates to fly to its next position. And then when it gets to the last, back to where it started, it'll stop. So it's almost coming to its execution now. And it stopped. So now, what I want you to do for a minute is, now that you've seen the process, I want you to think about how you might code that with your knowledge of game salad. And if you want to take a minute, pause the video, and I want you to draw a parallel between what I'm about to show you and what your thinking is. So just pause the video for a minute and give it a minute or two and think about how many rules and how you would execute what I just did. All right, so now let me show you how I did this. So let's go up, and I made a table and I called it route. And basically what I've got is a handful of things here. I've got my X and Y positions, and I've got the rotation. And I've broken them down into the legs of the journey. And you'll see in this last row I've got it set up as 0. Now the first leg, we have the first position of these are actually the second planet. So it's going to get its first coordinates while it sits at the first planet. So it's going to get where it's going and the angle it should be faced at. So it gets that before it goes to the next planet. So you got to make sure that actually it seems weird because your rotation position is actually going to be acquired with the next coordinate positions. Okay, so we've got all our coordinates here with the representative angles in this table. And then let's go ahead and go into our spaceship. And you're going to see basically what I've done is I've got fixed rotation and movable. And I've made one self-attribute I call route. Now, I like to use integers instead of booleans a lot of times with specific things, because here's why. With an integer, if you have a system like I'm going to show you now, where you have a series or a sequence of events, and you want those events to never happen at the same time. They're never ever going to happen at the same time, coincidentally. If you have a bunch of different attributes or a bunch of different booleans, there is a possibility that somewhere in your code you could be executing things where those two booleans are going to be triggered at the same time, which are going to trigger counter events. So let's say I had, a boolean for every route switch, and I'm telling my actor, if each one of these booleans were on to go to a different position. Well, if there ever was a situation where those two booleans got changed, now I'm trying to tell my actor to go to two different places, and that's going to present a problem. The reason why I like to use integers and use number progressions is because when you do number progressions, there is never a chance that you're going to be sending conflicting information to your actor. Because it's either going to be, it can only be one state. So it's either going to be the number 1, 2, 3, 4, 5. It can never be 2 and 3 together. It can never be 1 and 5 together. It's only going to do or execute what that one number says. So in movement progressions like that, I like to use an integer and step the numbers up. And I'll show you why that becomes even more valuable in code integration. Because we're going to see I use this one attribute to define information of completely different things in 3 different places to accomplish what I did. That's all this thing has, is one integer self-attribute. And I'm going to show you I've got 2 change attributes and a move to behavior, and 3 attributes that I'm keying in on. So now let's go ahead and look at the first thing. This is basically the start sequence. It's going to start the route. So I'm saying if the self route, this number right here, let me close this so we don't get confused. This self route number is greater than 0. So let's say that I want to have a button that would start it. I would change this to 0 and say when I would say, well, when you touch the ship, it'll change to 1. Pretty simple. We can just add a touch and press rule in here, and boom, we're off. But I just did it by changing the number to 1. So now what we have is I've used in this, since we could do it in the loop behavior in the nightly build, I want this to be for everybody. So I used the conventional method that we use now to keep a move to behavior firing. So I put in an every 0-second timer, and I'm running to completion. This allows me to only use one move to behavior for every single position we're going to be moving to. So with the every timer, it's going to keep looking for when there's new information, because we know that a rule, if I didn't put this in a 0 timer, when I start changing the place that it's looking for its next positional data, it'll just move to one spot and it'll stop, because a rule only fires when conditions change. Now you could do this in another way with adding a whole bunch of rules with when it's 1, when it's 2. This is the way I did it. So now what we're going to see is in our X position, what we've got here in the expression is I'm using a table cell value. In my route table, I'm assigning the row number. So we know the first row is the first series of coordinates, which is flying from the left position to it's actually the second planet, but it's the first planet on our route in our travel. Okay, and so I built the sequence so that the first information is in the first row. Now what this allows me to do is, as I change the route number, it's going to allow me to address the next row that my information is, and it's going to give me the X position. And it's in column 1. X, we know that's always going to be in column 1. Same thing with this, column 2. So we're always going to be looking for the row that the route is set to and what column, and I've got the speed set here. And then what I've done is I'm just basically going to monitor the X position of each one of the planets. This is each one of the destination values that we have in our table, the X positions, and we set it to any. And so now what I did was I came down here and I said, okay, when you reach any one of these positions in the route, go ahead and change self-route to self-route plus 1. And then also, after you've changed the number, go ahead and make the rotation swap. So it's the same way for the rotation. So now everything that I'm doing, from rotating to moving to all these things, are all being addressed by one attribute, which means all this code here will never ever conflict with each other. Never. You won't have to worry about things firing. And I did that whole sequence with 2 change attributes and a move to behavior and 1 self attribute. This begins to do a real basic understanding of code integration, of designing out your logic to function around a single attribute. And all the other aspects of your code in relationship to that can fire and move and be integrated in it. So you don't have to have tons of attributes and tons of rules and tons of conditions and tons of behaviors. This is where you really start to understand how to design logic and to develop it. I've got a game that I'm developing now that's a very complicated game, that everything that fires in that game and happens revolves around 4 attributes. And there is never any way in this game that things can get messed up, because everything, so if I change one number in one of those attributes, it goes through the whole sequence of things that are spawned and things that are scored and things that are done simply by changing one number in one of those 4 attributes. I can daisy chain and change the evolution of every other sequence and part in that game by changing one number. So this gives you a window into what it means, or the beginning to understand how to think in optimizing and making your code efficient. The more efficient your code is, the more integrated it is, the more centralized it is, the more simplistic the design, but yet you can still have the complexities that you need. This is what makes your game run efficient, not using timers and a lot of these other kind of tricks that, well, they work good if your code is bloated, because if you have 100,000 timers, yes, your game's going to bog down. So if you use self-time, yeah, it's going to make it easier. It's going to make your game perform better. But that's not why your game's having problems in the first place. It's because you open up an actor and you've got 80 million thousand rules in there and conditions and all these game level and self-level attributes that are just redundantly stacked on top of each other, and there's no thought that's gone into actually designing the code for your game. I do a lot of sitting down and writing out my code for really complex stuff, and I'll throw away 10 different working iterations of that code until I come up with what I think is the most refined version of it before I even begin working in my game. So many people are so eager just to jump in and make a game and do these things, and then you invest all this time, months of work, and you realize your game's starting to break down as the code gets heavier and heavier, and now you're like looking back going, I've got all these problems. And if you had just invested the weeks in laying out and designing, properly learning how to use Game Salad, properly learning how to do these things, you wouldn't be looking back 5 months down the road and seeing a lot of wasted work. And so, this is the ways to really make your code good, really grasp an understanding of integrated logic, and make your game run smooth and efficient. So anyways, this is Dave with Fry and Bacon Studios. I hope this helps you. I'll see you in the next video.